Boys and girls, good day to you again. How are you? Welcome back to physics again. Now let us go to another topic in physics that is very interesting, but sometimes students get confused. And what I mean is this topic on resultant force. But just before we go to that, let me encourage you again. In life, nothing comes easy. To achieve something, we need hard work, just like Mr. Ant. So let us remember the little ant who works the whole day non-stop, and once we are like the ant, we work hard and do it smart, do it hard, then we will achieve great things, even in physics. A good reminder again, to revise well in physics, you have to rehearse, you have to answer questions that are like past year questions. Now, in resultant force, in this question, let us look at it. There are two forces, F and G, acting on an object P. Now, F is given to be 3 newtons and G is 4 newtons. The angle in between, as you can see here, is 90 degrees. There are two parts to the question. Calculate the magnitude and the direction of the resultant force acting on P. So that is the question. Some students are confused about it one way or the other. Now let us look at it and see how to tackle this problem. From Perlis to Sabah again, we see one phenomenon among students. Some of them, they will have all kinds of answers. Maybe I can just show you some of the answers that they give. Maybe some of you give these answers. Is that the resultant force? Alright, so that is actually a wrong concept. And some of them, they will draw the line, either they go up or they come down. Any of these answers is wrong. Alright, because as you know, this cannot be the resultant force. How do we know that this cannot be the answer? Let me show you a video clip. A very simple but interesting video clip in the class. Now what I have here is this. The middle boy is object P. Alright, you look at the story, it is similar to the question that I gave, even though the angle could be slightly different. So we have one force F pulling him to one side, and we have G pulling him to the other side. So this is very similar to the question that is given. Alright, please look at what happens to P. The middle boy here is object P. Let's see what happens. He is being pulled by the two forces. So quite obviously, you will notice that there is only one direction that he can go. His direction is going this way. If you can follow my cursor here, the arrow, he goes this way. Let's look at him again. Alright, he goes in that direction. Alright, now let us now go back to our question. And now that we have understood the concept, that the resultant force must be in the direction as shown by X. So our job now is to calculate the value of X, the magnitude of X, and also we need to calculate one more thing. We need to calculate what is the angle, the direction. Alright, so the first thing that we need to do is, let's go to the diagram and see how we calculate X. Now to do X, because we have already understood the concept, so right now what we need to do is complete this rectangle. This happens to be a rectangle. Sometimes it is a parallelogram. Alright, so we work this out. Alright, I'll use another color so that it is clearer for you. I use two arrows. So this is x. And what is the value, the magnitude of x? So we can calculate. Alright, now this is also 3 newtons. This is 4 newtons. This is 3 newtons. So what is x? From theorem of Pythagoras, what we can do is that x square will give us 4 Newton square plus 3 Newton square. And what we'll get is 16 Newton square plus 9 Newton square. I will get 25 Newton square. So we need to calculate the square root of x squared, which is x. I write down the square root of this. And what will I get? 5 newtons. Alright, beautiful. So this is the magnitude or the size of the resultant force x. Now what about the direction? Just now I mentioned that for the direction we can call this theta. Alright, so let's come down to this. Okay, we want to calculate theta. Alright, so very quickly I'll just draw the diagram. It's good for you to draw it again, then you will understand it clearer as you do it many times. This is x. Alright, now we have already worked out that x is 5 newtons. Okay, x is 5 newtons and this is theta. So I want to calculate what theta is. So we use one of the trigonometry functions, isn't it? Is it sine, cosine, or is it tangent? Alright, so we know that it has to be cosine. So I can use cosine of theta. Cosine of theta, what will it give me? It is the force G divided by the force X. So this gives me 4 newtons divided by 5 newtons. Okay? And this is actually 0.8. The newtons is cancelled off. So from your calculator, you can tell me the value of theta here. Alright? So what is the value of theta? You punch in your calculator, you should be able to get the answer, isn't it? Okay? So, see some of you nodding your heads. That is 6.87 degrees. So, I have got the complete answer now. The direction, 36.87 degrees to the force G. Alright, that is the direction of the resultant force. The magnitude of the resultant force X is 5 newtons. So I have actually answered the question. So to sum it up again, boys and girls, remember, when you answer a question on resultant force, there are always two aspects. One is you must give the magnitude or the size of the resultant force. Number two, you must give the angle of the resultant force. Then that is complete. So go and try out other problems of the same from the same topic, and you will understand this very, very much better. So with that, I would like to say thank you very much, and may God bless you.